This is lesson 4.2, writing equations in point-slope form. Our essential question here is how can you write an equation of a line when you are given the slope and a point on the line? Our core concept here is point-slope form. A linear equation written in the form y minus y1 equals m times the quantity x minus x1 is in point-slope form. The line passes through the point x1, y1, and the slope of the line is m. So how are we going to use this here? In our example 1 here, we're using slope and a point to write an equation. We're asked to write an equation in point-slope form of the line that passes through the point negative 8, 3, and a slope of, sorry it didn't come out real, I don't know why, but this is actually supposed to be 1/4. So our solution here is we have that equation y minus y1, and remember y1, we have x1, y1, so my y1 is 3 here, equals my slope, which is 1/4, times the quantity x minus my x1, which is 8. But minus 8, minus a negative 8, I could just write plus 8. So this is it written in point-slope form. And we can leave it in that form because that is a viable form of writing. I mean, I know you see slope-intercept form a lot, but point-slope form is another way of writing an equation. So when you're given 2 points on the line, you can write an equation of the line using the following steps. Step 1, find the slope of the line. And step 2, use that slope and one of the points, it doesn't matter which one, to write an equation of the line in point-slope form. So in example 2 here, notice we're given 2 points now. And we're asked to write an equation of that line that is shown. So the first thing I need to do is define the slope of the line. So our slope is going to be equal to, let's say that this is my 1s, these are my 2s. So I've got negative 2 minus 2, change in y's, over my change in x's, 3 minus 1. So I get negative 2 minus 2, which is negative 4, over 3 minus 1, which is 2, which gives me a slope of negative 2. So now to write it in a point-slope form, I can do y minus y1, which I set up here is 2, equals negative 2, my slope, times the quantity x minus, use the same point, x1, which is 1. So this is going to be my equation. I could go ahead and distribute and simplify and put it in slope-intercept form, because I could do y minus 2 equals negative 2x plus 2. Add 2 to both sides. And we'll get y equals a negative 2x plus 4. It's now written in slope-intercept form. And it really wouldn't matter which point I used, I would still end up with the same equation. Okay, now for example 3, we're asked to write a linear function f. So now we've got that whole function notation with the variables of f of 4 equals negative 2 and f of 8 equals 4. Remember, I told you this is just a different way of writing 2 different points. This f of 4, remember, that means that the x is 4 and the y is negative 2. And the other point here, f of 8, means that x is 8. Because remember, it's always f of x. So that x is 8. And my y is 4. So now we have our 2 points, and we're going to do it just like we did the other way. We're just going to find our slope So to find my slope here, I'm going to take 4 minus a negative 2 divided by 8 minus 4. Remember, 4 minus a negative 2 is really, keep change, 4 plus 2, which is 6. 8 minus 4 is 4. Go ahead and simplify that, and you're going to get 3/2, or you could even write it as a decimal if you wanted, as 1.5, depending on how you're calculating things. And now we're going to use the slope of 1.5, and let's just use the 0.84. That's 8.4. Make sure you can read that. To write it in our point slope form. So we're going to have y minus y1 equals my slope, which is 1.5, times the quantity x minus my x1, which is 8. I can go ahead and distribute and simplify to get it put into slope-intercept form, because that's the easiest way for us to be able to graph. This would be 1.5x, and 1.5 times 8 is going to give me 12. Add 4 to both sides. And we are going to end up with the equation y equals 1.5x minus 8. That's the linear equation for this thing. But remember though, we were originally not asked to write the linear equation. What we were asked to write is the function notation. And remember, with function notation, all you do is take that y and put f of x in the terms. So now you just got f of x equals 1.5x minus 8. That's how it would be written in function notation. So how about when we're modeling with mathematics? A student council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the cost as a function of the number of foam hands. So first off, you need to break this down. Let's understand the problem first. You know 5 data points from the table. You are asked whether the data are linear, and if so, write a linear model that represents the cost. So let's make a plan. Find the rate of change for consecutive data pairs in the table. If the rate of change is constant, use the point-slope form to write an equation. Rewrite the equation in slope-intercept form so that the cost is a function of the number of foam hands. So then to solve the problem, we're going to find the rate of change for consecutive data pairs in the table. If we're looking here, we can find that 46 minus 34 we find that the slope is 6. If I try that with each of these points, I am still going to get that the rate of change, or the slope, is 6. So that means that since the rate of change is constant, that the data is linear. So we're going to use the point-slope form to write an equation that represents the data. So we're going to use the constant rate of change, or our slope, of m equals 6. Let's just go ahead and use the data point 434 so that we can write an equation. We're going to start off with letting C be the cost in dollars and N be the number of foam hands. So we're going to have C minus C1 equals my M, or slope, and N minus N1. We're just basically using N and C instead of X and Y. So to write that, we're going to have C minus 34, my cost, is equal to my slope, 6, times the quantity, N, minus the number of foam hands, which is 4. Go ahead and distribute, and I get C minus 34 is equal to 6N minus 24. Add 34 to both sides, and we're going to get that the cost is equal to 6 times the number of foam hands plus 10. Because the cost increases at a constant rate, the situation can be modeled by a linear equation. The linear model is C equals 6N plus 10. Go ahead, get your notes finished up, show me your notes, and begin on your clever assignment.